Hello everybody, welcome back to Grifted Drawings. In this tutorial, I'm going to show you how to analyze beams and draw shear force and bending moments. As you can see, we have a beam spanning a distance of 6 meters and it's loaded with a uniformly distributed load of 25 kilonewtons per meter, spanning a distance of 4 meters, and at the midpoint of the UDL, we have a point load of 40 kilonewton per meter, that is from A to point C, 2 meters, that is where we have the 40 kilonewton load, point load. And we also have another load to the right of support B, that is 25 kilonewton meter. So we are going to start by first of all calculating the reactions. So we shall start by stating the equations for static equilibrium, where the first one we shall go for is the summation of moments due to support A should be equal to 0. This means that total clockwise moments should be equal to total anti-clockwise moment. So we shall first find the total load for the UDL. So you shall take the load per meter, that is 25 kilonewton per meter, times the distance the UDL is spanning, that is 4 meters, so 25 times 4 to get 100 kilonewtons. Then we proceed. We assume that the UDL now is a point load and acting at the center. So we shall have 100 times 2 to get the moment for the UDL, plus 40 times 2 to get the moment for the 40 kilonewton load, plus 25 times 5 to get the moment for the 25 kilonewton load. This is equal to 4RB. So 4RB is therefore equal to 405 kilonewton meter. To get RB, you divide 405 by 4 to get 101.25 kilonewton. Then you go for the second equation of static equilibrium. Summation of forces along the y-axis should be equal to 0, meaning total upward is equal to total downward forces. So Ra plus Rb, which is 101.25 kilonewton, should be equal to 100 plus 40 plus 25. So Ra will be equal to this sum, that is 165 minus 101.25. Therefore, we shall find Ra to be equal to 63.75 kilonewtons. With the reactions done, you can go ahead and start drawing the shear force diagram. The shear force diagram starts from 0 and encounters a reaction force Ra, that is 63.75 kilonewton, which takes it upwards to the 63.75 kilonewton marks. Then the UDL starts acting, spanning 2 meters for 25 kilonewtons per meter. So it takes it to 13.75 kilonewton, where it encounters a point load of 40 kilonewton, which takes it to the negative 26.25 kilonewton, and the UDL again takes over, taking it to a further negative 76.25 kilonewton until it meets the support reaction B, that is 101.25 kilonewton, which takes the shear force diagram upwards to 25 kilonewton. The SFD then travels a straight horizontal line until it encounters a point load of 25 kilonewtons, which takes it back to the 0 mark. We now proceed to draw the bending moment diagram by finding the areas of the shear force diagram. For the first section, A to C, we use the formula half H into A plus B, that is 0.5 times 2 into 63.75 plus 13.75 to get 77.5 kilonewton meter. And plot the 77.5 kilonewton meter on the positive side of our bending moment diagram, since this is on the positive side of our shear force diagram. We draw this line using a concave line in nature, And then we proceed to get the area for the second section, that is section BC, using the same formula, half h into a plus b, that is 0.25 times 2 into 26.25 plus 76.25 to get 102.75 kilonewton meter. We subtract this value, that is the 102.5 kilonewton meter, from 77.5 kilonewton meter. Since our section is in the negative side of the shear force diagram, to get negative 25.25 kilonewton meter, that is on the negative side now of our bending moment diagram. Okay. Then we proceed to get the area for the rectangular section using the formula length times width, that is 1 times 25 to get 25 kilonewton. This is now a positive value, so we add negative 25 plus 25, it takes it back to 0, and draw this line using a slanted line. Thank you for watching. Please remember to like and subscribe and share the video.